Hi, welcome to 2-5 Notes, Day 2. These are proofs involving geometry. So yesterday in class, we went over the 2-5 Day 1 notes, and we were going over the algebraic properties, and we started doing some proofs with algebra. You're familiar with algebra already, so we're using algebra to help you kind of understand the process of a proof. Now we're going to review over some terms you learned in Chapter 1 that will help you with the proofs after going over the review. And then we'll do some geometry proofs. When we do the geometry proofs, kind of the hard part for people sometimes is getting the geometry part figured out right at the beginning of the proof. But then once they set up an equation and they're just solving the algebra, it becomes easier. It's more like the day 1 notes. But again, a lot of the proofs end up being very similar to each other. So you'll start noticing some patterns and you'll get the hang of it with some practice. So definition of congruent segments says that if the segment WX is congruent to segment YZ, then the measure of WX must be equal to the measure of YZ. Okay, or the alternative of that is if the measure of WX is equal to the measure of YZ, then line segment WX must be congruent to line segment YZ. Okay, so really this is just switching from the congruent sign to the equal sign or switching from the equal sign back to the congruent sign. You cannot work out algebra with a congruent sign. You have to have an equal sign. So if the proof starts off in congruent symbols, you have to turn it into an equal sign before you can do algebra. It's kind of a key thing. All right, segment addition postulate we went over in chapter 1. It says if A, B, and C are collinear, again, meaning all on the same line, then what? So I think it's helpful to see a picture of it. So if we have A, B, and C here, switch colors here, then like we talked about, A, B, and C are collinear, and it says AC is equal to. So I can see AC is this whole length, and the two things that I know that add up to AC would be the measure of AB and the measure of BC. Okay. All right, next one is the midpoint. And I guess it probably would be better to say definition, if you want to add this in, of midpoint instead of just midpoint. So definition of midpoint, and it's a point that divides the segment into two, so I'll put a 2 there, two congruent segments. And I can draw an example of that. If I go ahead and draw a line segment, and I'm going to label X and Z on the end, and I'm going to put Y in the middle. And again, if I saw congruent marks on this segment and this segment, then what I could say from that is I could say that Y is the midpoint of line segment XZ. Okay. And because again, if Y is the midpoint, then I know it's going to be congruent on each side. And again, all of these reasons we're reviewing of right now will be reasons in the proofs that you end up using. So linear pair theorem, linear pairs are supplementary is the key thing there. Okay, we know if you have a linear pair, which again, it's two angles like this one and this one forming a straight line, then we know that those two angles must be supplementary to each other and therefore add up to 180. Okay, let me go and move it up from there. All right, next one is definition of supplementary, angles that add up to 180 degrees. Don't forget about the examples that we went over in chapter 1. Supplementary angles can be two completely separate angles. Say I call this one 1 to 50 and this one 30. That would be a pair of, I could say like angle A and angle B are supplementary. Okay, but I could also have a linear pair, two angles forming a straight line, and those two angles could also be supplementary. Okay, complementary is very similar to that. Definition of complementary are angles that add up to 90 degrees. And again, you could have two separate angles that add up to 90. Say I have a 45 and a 45. Okay, but I could end up having an angle that is a right angle, and say I have two angles here and here that form that right angle, then I could say those two angles would be complementary to each other. Okay. All right, from there, we are going to start a geometry proof. So I would like you to be able to see the whole thing. Let me see if I can reduce it down a tad bit so you can see the whole proof. Okay, there we go. So here you can see, it's kind of a key thing here. You want to be able to see that picture up at the top. You want to be able to see the given and what you're trying to prove. You can see here our given is that angle AOM and angle MOD are a linear pair. They are showing us a picture this time, and we can see that one angle is 3x plus 60, the other angle is x. And we can see we're trying to prove that x is equal to 30. Remember, that means they're giving us the answer, and we just have to work to get to that answer. Okay, so like we talked about on day one, we need to write the given information in as the first statement. So angle AOM, put the and symbol, and angle MOD are collinear. Okay. Oh, I didn't mean to say collinear. I meant to say a linear pair. So let me get that fixed. So I'm running out of room, so I'm going to go up here, linear pair. Think about what that first reason is. I said you never want to miss the first line of a proof, and that is given. That is our given information. That is our starting point. Okay, so from there, if we know that two angles form a linear pair, we have to think, what else is something true we can say about those two angles? And that would be, again, you're using some of the information that we wrote down just above on this paper. And so the other thing we would know about those two angles for sure is that angle AOM and angle MOD are supplementary. And I'm just going to abbreviate supplementary since I don't have a lot of room. And then I have to think about what that reason is. And the reasons are up above on this paper. And in this case, that would be the linear pairs theorem. Okay. From there, remember what I said is that I can see what I'm trying to prove has an equal sign. So I know that I have to set up a true equation and solve for x. And I have to bring an equation right now into this proof if I'm going to be able to solve for x. And I don't have an equation yet. So if I think about these two angles being supplementary, something else I know about them then is that the two angles add up to 180. So I can show that by saying measure of angle AOM plus the measure of angle MOD must be equal to 180. Okay, the reason we can put there is definition of supplementary. Okay, I know that if they're supplementary, I therefore know that they add up to 180. All right, from there, now if I look at that picture, I can see, well, I know angle AOM is 3x plus 60, so I can put that in this spot. And I can see that angle MOD is x, so I can say plus x, and then equals the 180. Okay, so think about what did I just do? I put some algebra stuff on the picture in for those angles, so that is substitution. Remember the substitute teacher coming in place of the teacher, okay, replacing the teacher for the day. All right, from there, we need to, now it goes back to the day one reasons, and we're basically just doing the algebra on the left, and on the right are going to be those algebraic reasons from day one. So again, sometimes there can be some variation in the way people solve. Sometimes it's kind of forcing you to do it a certain way. But in this particular case, I can see that I have some like terms, the 3x and the x. I can go and combine those together and say 4x plus 60 is equal to 180. And then again, think about that reason like we talked about in class recently. If I took the 3x and the x, yes, I added them, but I am not going to say addition property because I did not add something to both sides of the equal sign. That 180 stayed the same. So if I'm just replacing 3x plus x with 4x, then that is actually substitution. Okay. From there, I want to solve for x. So next thing I can think of is I'm subtracting 60 from both sides. So I get 4x is equal to 120, and that is subtraction. And then from there, I can divide by 4 on each side to get x equals 30, and that is division. All right, so hopefully you enjoyed that first geometry proof, and now let's do another one. Okay, so again, the idea is we're taking the given, we're working towards the proof, we're using the picture given to us, and again, if I see that we're trying to prove x equals 3, I know that I'm going to end up having an equation in there, and I need to get to that equation. So on this one, you should already know how to get the first line of the proof. Again, I'm going to write the given. M is the midpoint of EF. Okay, and again, that is given. All right, from there, look at the picture and think about what does it mean if M is the midpoint? I have to know what those words mean. So midpoint means middle. And if M is right smack dab in the middle of E and F, then I therefore know that these two pieces are congruent. So I need to say that in my proof. I can say segment EM is congruent to segment MF. All right, and that reason is definition of midpoint. I knew what that word meant, so I knew that I could mark those congruent. So definition of midpoint. From there, remember, to do an algebra equation, I have to have an equal sign, and I don't have an equal sign yet. But I can turn the congruent symbol to an equal sign, and I can drop the line segment symbols on top. And now this says the measure of EM is equal to the measure of MF. And that is one of the new properties we learned today, which is definition of congruent segments. Some people just say definition of congruence. I usually say definition of congruent segments if I'm dealing with segments, and definition of congruent angles if I'm dealing with angles. All right, now I'm ready to look at my picture and plug stuff in from the picture. So I can see that the measure of EM is 3x plus 4. I can see the measure of MF is 2x plus 7. And again, what did I do? I just put something into something else's place, and so that is substitution. All right, from there, it's time to do algebra. Remember, like I said in class yesterday, doing the algebra part of a proof is kind of like a choose your own adventure book. You might do it one way, I might do it another way, but we can still end up with the same answer. We might not do the same number of steps, though. It kind of depends on your choices there. So I am choosing to subtract 2x from both sides. Again, like I said yesterday, if it helps you to, kind of write kind of small and little and show that you're going minus 2x on both sides, you can do that. Some people like to do that and it's helpful to them. Some people kind of feel like it makes the proof too messy and they don't want to. So that's up to you. But if I subtract 2x from both sides, I get x plus 4 is equal to 7. And again, what did I just do to both sides? On line 4, to make it look like line 5, is I subtracted. So I'm going to write the subtraction. All right. From there, I can see that I am adding 4 to both sides. Again, if that is helpful to you. Not adding 4, I meant subtracting 4. I want to do the opposite operation. So if I go minus 4 from both sides, then I end up with x equals 3. And again, what I got here is the same as there. So that helps you know I'm done with the proof. And I should get the same thing. Don't just automatically write x equals 3 at the end. You need to make sure you actually get and solve to x equals 3, or there'll be some incorrect things up above. And the reason for that is subtraction once again. All right, moving right along. Okay, on this next proof, then we have, it says that AC is 51. So if they give me some information that is not already marked in the picture, I'm going to mark that in my picture. That's going to help me figure this out. And it's telling me that the measure of AB is equal to 8. So that's a little different. It's not saying X equals 8. It's saying that the measure of AB is equal to 8. But I still know that I'm going to have to set up a true equation. I'm still going to have to solve for X. And then I can plug back in for what it's wanting me to prove. So again, I need to get my given here that AC is equal to 51. And that is given. And then if you're kind of stuck, like, where do I go from here? Look at those choices up above in your notes and see if you can figure something out that applies to a picture like this. Okay, and the thing that I came up with is that segment addition postulate. I can say this little piece AB plus this little piece BC must be equal to the whole piece, which is AC. And again, that is segment addition postulate. That one gets used quite a bit. Abbreviate some of that since I'm running out of room. So segment addition postulate. From there, I can look at the picture. I can take information and plug it in. So AB is 2x. BC is 9x plus 7. And AC is 51. And from there, that is, again, substitution. All right, from there, again, I can see that 2x and that 9x. I'm going to combine those like terms together to get 11x. And again, I did not add something to both sides of the equal sign, so I'm not going to say addition. I'm going to say substitution. Substitution ends up getting used a lot. Okay, so from there, now I can go and subtract 7 from both sides. Okay, and so that is subtraction. And then I can go and divide by 11 on both sides and get x equals 4. And then from there, again, I'm not to what I'm trying to prove yet. This is what I'm trying to prove. And so to get there, I can show that the measure of AB is equal to, if I look in my picture, I can see AB is 2x. But if I know that x is 4, I know I can put a 4 in its place. And then I know that 2 times 4 is equal to 8. And so now I have that AB is equal to 8. You can write that as a whole separate line to say AB is equal to 8, but it's sufficient just to put what I have in number 7. And I'm kind of showing where I got that from. And again, this is not multiplication, even though I just multiplied 2 times 4. I did not multiply something on both sides, so that's why it's not multiplication. And it would be substitution instead. Because again, we're putting something different into something else's place. Okay. So from there, we've got 2 more proofs to do. And then there's just a couple of reminders up here at the top. So up here at the top, it says, in addition to the algebra properties, the following definitions and postulates can be useful in proofs involving segments. Let's review. So some of these we already kind of reviewed over. So I'm just going to fill that in real quick, that if there's a congruent symbol, we can switch it to an equal sign and drop the line segment symbols on top. Or if it's an equal sign, you can switch to the congruent symbols and the line segment symbols on top. Okay. Segment addition postulate, again, I can say that AC, the whole thing, is equal to AB plus BC. All right, midpoint is a point that divides a segment into 2 congruent segments. So it's the middle. All right, so if we look at this proof that is in the notes, then it says what's given is that segment AC is congruent to segment BD, and we're trying to prove that segment AB is congruent to segment CD. So if I look at this, what's given is that AC is congruent to BD. Okay, so I know this one is congruent to that one. It's hard to see here. All right, and then I also know that AB, so from here to here, is congruent to CD from here to here. Okay, so it helps just kind of make sense of what we're doing first. They can see they gave me a little bit of information. I need to fill in from there. So here's my given information. Okay, from there, remember, I can't solve stuff with the congruent symbol. So I need to switch it to an equal sign. I know if they're congruent, then I can say their measures are equal to each other. And so that is definition of congruent segments. Okay, from there, I can see that I can use segment addition postulate here. Remember, again, two little pieces add up to the whole piece. And so I can say that AC is equal to AB plus BC. I also can say that BD is equal to BC plus CD. Okay, so again, the two little pieces add up to the big piece, and that is segment addition postulate. That is a reason that gets used a lot as well. Okay, from there, change colors here. Okay, so here, if I know that AC is equal to all this stuff, I can put all that stuff in for this AC's place. And if I know that BC plus CD is equal to BD, I can put all that in for BD's place. So what it looks like on the next line is I could say AB plus BC, okay, because the red just got put into AC, is equal to BC plus CD. So the purple just got put into BD's place. And you're allowed to do that since they're equal. And if you put something into something else's place, again, it's substitution. All right, from there, like we were doing the properties on day one, if I look at line 4 and think, what do I do to get from line 4 closer to what I'm trying to prove? And I can see that there's a BC on each side of the equal sign. And if I subtract that away, I'm left with AB is equal to CD, which would make sense. Again, what did I do to both sides is I subtracted. So I'm going to write subtraction. All right, and from there, you can see they already filled in line 6 for me. I'm switching from the equal sign back to the congruent sign. And so that is definition of congruent segments. And that's it for that one. So one more, you can do it, hang in there. Last one, if you want to go and try this one on your own before you see what I have, feel free. If you want to go ahead and do it with me, so you can pause the video and try it yourself. If not, you can do it with me as we go. I'm going to make it a little bit smaller so you can see the whole thing. There we go. All right, so it says C is the midpoint of BD. So I have to think about what that means is that I know that this piece must be equal to this piece, right? If I know that C is the midpoint, but I need to say that in the proof. I can't just go with it being the midpoint. I'm going to have to say something about that. And also AB is congruent to DE. So I also know that AB, I'm going to put 2 marks there, is congruent to DE. Okay, and what I'm trying to prove is that AC is congruent to CE. Okay, so always keep in mind what you're actually trying to prove. In this case, I don't want to mark them congruent yet because I haven't proven it yet, but I'm basically trying to say that this is the same thing as this. Okay, so what's in red is what I'm trying to prove. So I know that my first reason needs to be given, so get that put in there. Okay, and from there, again, if I said C is the midpoint of BD, I have to say something else about what I know from that, and that's the fact that BC is congruent to CD. And I put my line segment symbols on top, and that is definition of midpoint. I knew what that word meant. Okay, and if I find something out as I go, I want to mark it on my picture because that might help me find the next thing. So I just said BC is congruent to, I'll put 3 marks on it, CD. 3 marks on it. Okay, from there, I can go ahead and switch from the congruent symbol to the equal sign. So you can see up in the first line, I said AB is congruent to DE. Well, I can switch that to the measure of AB is equal to the measure of DE. Okay, and then I can also take line 2 and switch it from congruent to equal sign. So I can say BC is equal to CD. I don't want a line on top there. So that's kind of a key thing. So BC is equal to CD. So the measures are equal, and that is definition of congruent segments. And again, that is just if you're switching from the congruent sign to the equal sign or the equal sign back to the congruent sign. All right, next step, if you look at your picture, you can kind of see there's some pieces that, all right, the two little ones would have to add up to the big one, two little ones would have to add up to the big one. So in this case, I can see that AC, look at your picture, is equal to AB plus BC. Okay, and I can also look to see that CE is equal to CD plus DE. So CD plus DE. All right, and all of that is, again, the segment addition postulate that ends up getting used a lot. Okay, so segment, oops, I forgot the word addition. Actually, let me rewrite that. Sorry about that. Forgot a word. So I'm going to abbreviate that as segment addition postulate. Okay, because I didn't think I was going to fit the whole thing. From there, similar to what we did before, is that I can say that AC is equal to DE plus CD. Okay, always keep in mind what you're actually trying to get to. And in this case, I am trying to get to the fact that AC is converted to CE. Okay, I can see AC in line 4, but there is no CE in that same equation. So somehow I need to get it into that equation. Okay, so if I go ahead and basically say that if AB is equal to DE, I can put DE in for AB's place. And if BC is equal to CD, I can put CD in for BC's place. Then that's how I'm rewriting this line 5. I can say AC is equal to DE plus CD. And it's the measure of these. Again, putting something into something else's place is substitution. All right, and then from there, I'm trying to get to AC and CE. Well, we can see right here that DE plus CD is the same thing that I see right here, DE plus CD. They're kind of on different sides of each other, but same thing, and I can see it is equal to CE. So that's what I can put in here, is that AC is equal to CE. Okay, and that is substitution, again, putting something into something else's place. All right, and then the last thing here is switching from the equal sign back to the congruent sign to so that it looks like what I'm trying to prove up here, that AC is congruent to CE. Okay, and again, that is definition of congruent segments, and that's anytime you're switching from congruent to equal or equal back to congruent. Okay, so thank you for joining me. Hopefully you're getting the hang of it. You're going to do some practice with some of these proofs, but feel free to use the examples in the notes as you're doing the practice, and I think that will help you to get the hang of it. If you're having questions, feel free to message me or get on one of my Zoom help sessions. And have a great day.